All right, today we're going to be looking at solving two-step equations. In this video, we'll give an introduction and solve a few basic examples. And the method that I like to use for solving these equations is called the onion method. And the reason I use this method is because it is often difficult to figure out which step to do first. And if you look down here, we have 2 times h plus 3 equals 11. And the question becomes, do you deal with the 3 first or do you deal with the 2 first? And the onion method can help us figure out which method to do, or which number to deal with first. And so we're going to build an onion, and I'll show you how to do that with your variable at the very center of the onion, at the core of the onion. And we're going to do that by following order of operations, which is parentheses, exponents, multiplication and division, and then addition and subtraction, also known as PEMDAS. Okay? And then to solve the equation, you will peel the onion, and the outermost layer first is what you will deal with first in working towards isolating for your variable. And then, of course, just like always, we want to check our solution. So let's get started on this first one right here. I have an image over on the right that I found on the web that shows the onion as well, and I will try to replicate that a little bit on my hand-drawn equation. So we have 2h plus 3 equals 11. I am going to circle my h, that's the core, that's what I want to know first, and then I will follow order of operations. We have a multiplication times 2 and an addition of 3, and multiplication comes first in order of operations. So we're going to circle that, including what we've circled before. And then we are going to circle in the 3 as well. We don't really need to extend our circle across the 11 at this point. Okay, so we've built our onion. Let me actually copy that here, and I will we can work on gradually peeling the onion here. Okay, so let's peel our outermost layer, and that is the purple circle. So we will peel that away, and the 3 is available to us. So let's work on dealing with the 3. Let's subtract the 3 from both sides. And that gives us an 8 over on the right. The 3's cancel. And let me see if I can do a copy again. And we get a 2h is equal to 8. Okay, and then we've reduced it down to a simple one-step equation, which should be straightforward, but I will follow the onion model again, and let's keep peeling our onion. We're going to peel away that outer layer. It looks like we have a multiplication by 2, so let's divide both sides by 2, and these 2's cancel. 8 divided by 2 is 4, and we are left with just the h on the left side. So it looks like we've solved it. We're going to do a quick mental check to make sure. Is 2 times 4 plus 3 equal to 11? 2 times 4 is 8 plus 3. Yes, it checks out. Okay, so at least do a mental check. Your teacher might want you to do a formal written check as well. So that's the onion method right there. We build the onion and then we peel it away, and as we peel away the layers, it tells us which operations to undo first. Things get a little bit more complicated when we're dealing with fractions. So I am going to, on one of these, build an onion, and on the other one, I'm going to do it without building the onion. So let's build the onion here. Color doesn't really matter, but I'll try to follow that same model before, where the X was circled in black, and then we have to follow our order of operations. And the plus 3 happens next. And then lastly, the division by 15. A quick aside here, and I'm going to do this right down here. You might be curious about why the x plus 3 happens before the division by 15. And that's because fraction bars act as an implied grouping symbol. So there's an implied set of parentheses or brackets at the top of that fraction bar. So the 3 is more tightly connected to the x than the 15 is. Okay, So let's work on peeling the onion. Let's multiply both sides by 15, and I will try to model that. Let's see. I'll do a times 15 over here and a times 15 over here, and that turns into an x plus 3 once these 15s cancel. We have an x plus 3 equals 60, and then we will subtract a 3 from both sides, and we will end up with an x is equal to 57. I'll do a more formal check on this one. Is 57 plus 3 divided by 15, we're curious, is that equal to 4? Is 60 divided by 15 equal to 4? It is, it checks out. So our solution to this problem is x equals 57. I'm going to contrast what we just did with this next example that also has a similar setup, although I think you can see that the subtraction of 3 is not embedded in the numerator of the fraction. So I think you can tell that we're going to be adding the 3 first. So let's do that. And this minus 3 plus 3 cancels out. X divided by 2 is equal to a negative 6 plus 3 is negative 3. Let's deal with the division by 2, and we'll do that by multiplying by 2. And these 2's will cancel. We have an x equal to negative 6. You might want to pause a little bit. This looks a little bit curious. We ended up with x is equal to negative 6, and we started with an x is equal to negative 6 as well. And so that makes me think, should I double check my work? And I think it probably makes sense to do a formal check here as well. Is negative 6 over 2 minus 3, is that equal to a negative 6? So we can simplify that. Is negative 3 minus 3 equal to negative 6? It is. It checks out. So we did do the correct answer. We got a little bit of an interesting answer, but we did do it correctly. And that's a good place to stop right there.